Arham Ansari, a 25-year-old civil engineer. I'm really excited to learn what you've been doing to do with flood prediction, flood modeling. So welcome.
Thank you for having me, Mr. Will, and it's been an honor. So yes, I'm a civil engineer. I've been preparing for competitive exams in my country. Those things are really tough, like having 100,000 people competing for positions in a government, lowest level government jobs, which have vacancies of 10 to 20 jobs. So it's so competitive. And the main thing about these exams is cramming. So you have to just keep on repeating the same things to recall in an exam. And that's what I'm doing for last 2 years, 3 years to say. And in my free time as an escapism, as to do something meaningful, I've been trying to create various tools to help out visualize the environmental impacts and these phenomenons that are going around us, such as the heat waves and these floods. Try to make something out of it.
Okay, and I've seen some of the LinkedIn posts you've been making along the way to hook people in, have an interest in what you're achieving. So an example of one that caught my eye a couple of weeks ago, and just quoting you here, I just made my flood prediction model 24% less accurate. And it's the biggest breakthrough I've had. So what I appreciated about you saying this is that you're being honest. Usually LinkedIn posts are boasting about making things more accurate, not less. So yeah, this as I said, caught my eye, and is enough of a basis really to get you on the podcast and start talking about efforts really around the world to respond to the current season of flood events. The US audience is, of course, aware of what happened in July with Camp Mystic. Several, more than 100 people in Texas were lost during that overall event. But I understand that there's also floods of a large magnitude in India.
Yeah. So there has been three major floods and various lots of minor floods in India as well. And some of them were flash floods, some of them were general floods, but the main thing behind those were destruction and the lives that were lost, the agricultural losses, and in general, the destruction to communities. As a country that India faced just this year from all these sudden floods was devastating, the least to say. And as you might know or not know, floods are the most devastating natural disasters. So these are not just small things that comes and goes, but something on a global scale for any country. As I was saying that floods are 50% of the natural disasters that are occurred every year, not just in India, but around the world, especially flood-prone areas such as Brazil and uh, India as well, where floods are a yearly thing, sometimes even monthly, going through rainy season, sometimes not even rainy seasons, the snow melting and the dam breaking. Even though these are smaller things, but these does occur and destroys lives. And because floods, you can never prepare for such disasters, and these are never small scale.
Yeah. So what is the scale of the disaster that's happened in the past 3 months relating to flooding around India? Do you have any numbers in terms of lives lost or the financial
Sure.
impact?
So as you know, Indian currency is you can say $1 is like 90 rupees in India. So any number I'm going to give the numbers in US dollars, but in India that's 90 times more, just for context. So there were nearly 1100 lives which were recorded to be lost, and in injuries in thousands, and many missing cases and such, and the devastation. I'm not you. I can just give you an estimate. It's the estimate of the destruction cost, the cost of rebuilding, and the relief funds that are provided to people, the agricultural support, food supports, and temporary housing, and all that is nearly
US dollars.
US dollars in India that was spent and will be spent. This is currently an estimate with all these things in mind. So, yeah, and this is just for this year. Around the world, just this year, this estimate goes over 10, 20, 30 times, 90 to $100 billion.
Yeah.
So that's the scale of floods.
Okay, so clearly then, just on the basis of the lives lost, let alone the people injured, let alone the farmers who have lost productivity and an income from their farms, plus the financial damage. I like that you mentioned it's not just the damage to infrastructure, but the cost to rebuild and the cost to compensate people for loss of productivity. On those two factors alone, clearly this is a worthy topic of analysis, application of the first principles that we have in disciplines like engineering, geospatial, even mathematics. It's a great topic to bring to bear, to focus our attention and really make an impact to improve lives, to save lives, actually. Okay, so I think we have some nice context there. Right, so something else I just want to mention before we get going into your presentation is because of these sorts of things and because of the hook that you put out on LinkedIn, I liked what I saw, and I just happened to be going to New York City last week to be the MC for a tech workshop about open data and applied risk analysis. I was invited to do that by Priscilla Cole, who runs Geospatial Risk. Anyway, so it was just great timing because I offered to you the chance to give a 7-minute presentation over Teams to this audience in the St. John's University library on level 1 in this building in Manhattan. And yeah, you agreed, and thankfully the internet held up, and that Teams call we're able to pull off. So yeah, it was just great serendipity and a really nice extra bit of interest for this event for the upwards of 50 audience members that we had. So yeah, how was that experience for you?
So how would I say that this coincidence is just so deep that it just mind-boggling for me. Uh, a few weeks ago, I met Mr. Ryan. He he was also making a flood model.
Ryan Kmetz, Kmetz.
Yeah,
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 same here. I've met him in the past couple of months. Yeah.
yeah. So he messaged me. We connected. Then we talked on WhatsApp, and we talked about how much different our approaches was. He was a geospatial expert building something with all the knowledge he has gained over the past year, over the lifetime of geospatial analysis expert. And I was a civil engineer who was taking into account these parameters that usually people who are not from this field ignore. So we were discussing about our approaches, and he told me that he was going to give a presentation or talk about it on September 10th at a geospatial risk event with Priscilla Cole and few others. And he told me that if there is a chance, he might introduce me as well. And I was like, sure. So, but the thing was, I couldn't attend the event as it was very late at night. I was trying to wake myself up. I'm usually a insomniac. A few days ago, I didn't sleep for last 3 days, and I suddenly just had to be asleep when the presentation was going on. So I joined in last few minutes, and I saw him talking about final giving his final words and such. So we talked about after, and he told me it was good and all that. So I I didn't thought I was like, if I could have gotten that chance, it would be so great to, you know, talk about it with experts and put it out for the world to know. And just after week after that, you messaged me when I put out my post, and we talked about it. And on the same platform, same event, same person, Mrs. Percelia Cole,
Yeah.
you invited me to that, and I was like, what is going on? Like, is someone into? Is it kind of joke or something? So I just played along, and it did happen, the event, and many people messaged me after that event saying they liked the presentation, and people were applauding twice, and
Yeah. It was
how
funny
they
because
were
like,
interested in it.
yeah, so first of all, I didn't realize I wasn't the first one who invited. It must be strange for you being over in India, not knowing about anything that we're doing, and then
Yeah,
suddenly, yeah, this is how the internet works. It breaks down these barriers. And yeah, Priscilla Cole, I mean, I made a joke on LinkedIn that she owns New York City, but it's sounding like she owns more. Um, but yeah, like I'd never been, to that library before. Like we started organizing it sort of like I walked in 90 minutes early and they had the wrong kind of monitor up. It didn't have any speakers. In the end, the second monitor they found, we couldn't get the sound to work anyway. So we had to get a Bluetooth speaker. So you were speaking from a Bluetooth speaker on a desk in front of, like in the middle of the audience. Um, and the camera didn't work on the laptop that the library gave me to use, so I couldn't show you who you were speaking to. And then, yeah, as you said, when everyone clapped, the microphone on the laptop didn't pick it up. So, but another thing was because like I was the MC, and the main thing on my mind was the timing, because if we had drift throughout over the 3.5 hours, then that would eat into the time for each speaker, so I had to be very disciplined. So every single speaker, when there was 1 minute to go, I interrupted their presentation and told them just to keep them to time. And then, at the end, Priscilla was joking that, even for you, giving your presentation from India, I even interrupted you. And there was, because like apparently like you didn't hear what I said, so I had to interrupt you again. Anyway, so
yeah.
just to say,
I
maybe,
The thing was, you did told me that you would interrupt me in the last minute, but when the last minute was, you said 1 minute, and I was like, he was going to say something. Like people usually say 1 minute, I have something to say, or just a second.
uh,
So I was like, yeah, he is going to ask something or say something, or my connection is bad or something. So I stopped, and I was like, okay, I'll wait.
yeah,
And then you reminded me that 1 minute to go, and I was like, no, I messed up. So I
no,
started as soon as I can finish. I just ran through it.
yeah. Anyway, I think for what it was, we managed to pull it off, and it was a nice extra addition to the event. It provided some meaningful context for what was discussed, um, especially around the impact on people's lives and on the community of the kinds of analyses and first principles that were applied by the 12 presenters, including yourself. So yeah, I think we need to do more of it, and yeah, we definitely need to also improve the communications technology so you can be a real participant. But anyway, okay, so yeah, with all of that said, uh, we have tempted the audience now for the podcast. They want to understand, what is it that you've been examining? How have you built up a flood prediction model now that we understand the kind of positive impact that this can have?
Yeah. So what I'm trying to build is not just a model. Like there are various models out there, flood prediction models that would be many times more accurate than what I am building, because they rely on very expensive sensitive sensors, which, as you know, those are really high tech top of the line sensors which are being used to visualize if there would be a flood or not. And these data that those sensors produce, you can say you cannot be more sure about that data. So the big countries, the first world countries, which has developed so much that they can even predict if there's going to be a flood or not, disasters to prevent them, to warn their people. That's the kind of thing I wanted for my community, not just my community, but people around the world to have. But without relying on such expensive technology, such black boxes which you cannot trust fully, because as I said, around the world, flood happens for various reasons, not just for one or two. You cannot just say if it's raining heavily, it's going to be flood, because it can be yesterday there was heavy rain, but that rain created such an atmosphere that even just a bit of rain today can cause flood. These type of things I wanted my model to learn, to understand the environment that are flood like or can cause flood. That's what I'm trying to build. And because I am resourceless, n- uh, having no funding and no money to put in it, as I said, I was a student. I am building everything for free. So whatever I can build for free, I can provide for free as well. My time, as I said, this was what I was doing for fun. So I wanted not to get paid for my time, but I guess get acknowledged for what I'm trying to do, at least to help as many people get those warnings, those indicators that something bad could happen at any time. That's the goal. That's the impact I want for my tool to have. That's why I'm trying to create these interesting posts which hook people like you to spread awareness that there is something that I'm doing to, not just publish it at one day and for people to not even know something like this exists. That's why I'm going to talking about it as much as I can.
Okay, so around the idea of a purpose, then there is, as discussed, it is flooding is responsible for around half of the community impact of the different types of natural catastrophe events that can occur. This reflects or continues a theme actually established by Juliette Murphy on the podcast in the episode about flood map, where she contrasted flooding with fire and the fact that there are laws around having smoke and fire alarms in houses to help stop the spread of fire, but there isn't a similar regulation or building of early warning systems or flood alert systems, despite the fact that floods cause more damage than fire.
Yeah.
So I think we've established the purpose there. You've begun to talk about the difference. You've talked about large, expensive, maybe government funded or systems funded by large corporations. I mean, we've got First Street, we have Fathom that has also been on the podcast. They're very large, well-funded, as you said, systems that offer regional, nation scale, even global scale flood prediction. But you're saying that in countries or communities where there's less access to the resources, the funds to pay for these systems, or even the computing infrastructure, perhaps also to run these systems, there's a gap that can be filled by efforts like from yourself, using free data, offering something for free that can nevertheless have an impact and reduce some of those lives lost. Is that why what you're doing is different?
Yeah. What I'm doing is, yeah, it is surely different because what I'm providing is totally open source. So people can understand that how it would fit their environment. What I am building is totally free because as I said, I do not want anyone to think that these indicators, these warnings would come with a cost for their monetary funds and such. And it is different because it does not rely on any expensive setup or constant monitoring and constant maintenance and needing a scientist, engineers to understand to tell people what is going to happen, what currently being predicted and such. What I'm trying to build is something that would on its own tell you everything you need to know as simple as you can understand. This is what's most important right now to understand for you to understand why the thing I'm building is different from any other model that people usually build around floods. So what people who do not understand these technicalities usually think of floods as heavy rainfall. When there is heavy rain, people think there's going to be a flood, there is chances of flood, but sometimes even cloudburst would not cause a flood. It is a
So are you
bold
saying that
statement.
rain is a parameter?
Yeah, I'm saying rain is not the major parameter which people think it is. Everything flood happens because there are hundreds of different physical features, environmental parameters, which all contribute for a flood. These parameters are, you can say, the basics of what I want my model to learn from, not just understand that there was rain, so there might be flood. No. Let me give you an example. So, as I was saying, the Uttarakhand flood, how it happened was usually floods happen with lot of rain, but that day, on the day of flood, there was only 2.5 mm rain, which is not a lot. It's usually what happens in a on a simple rainy day. So not a big flood like situation, but a very deadly flood happened that day. It nearly destroyed half the town of Dharavi. So what happened that day is the day before that there was heavy raining, which caused all the soil to hold moisture up to 90% of the moisture, which loosen up the soil. That area has lots of vegetation, but those vegetation could not hold the ground as firmly as they should have because of all the moisture. The soil there is very light soil, and that area is very steep. So in conclusion, you can say it is a flood prone area. So the day previous raining caused the area to be more flood prone. So much so that even just a little bit of rain caused a flash flood, and in an instant wiped out half of the town of Dharavi. So that's parameters what I'm talking about. My model does not learn from rainfall. It learns from 100 plus parameters. Parameters such as the soil wetness, the aridity of soil, how much vegetation there is, how much rain there was 1 day, 3 days, 7 day prior, what was the precipitation, what was the runoff, the how much water runoff, how much water got into the ground itself, and many things such as the slope, the elevation of the area, how much high it is to the ground, the curvature of earth. People usually ignore the curvature of earth. It is an interesting fact. When you see straight ahead, you would see flat earth. Anyone would. But when you take into account area, which is more than 25, 50 kilometers, what happens is you would get fluctuations because earth is not flat, it is curving at a very small angle, and just a 25 kilometer area would give you a fluctuation of 20, 30 meters, and a 50 kilometer area which my model considers would give you a fluctuation of 200 meters of water level. So you can understand it like this way. If I do not tell the model if I do not tell the model the curvature of Earth, the model would think the water level is as high as a skyscraper. You
Wow.
can see the difference, right?
I love this way of explaining it.
Yeah, as high as a skyscraper, and a normal river water level is so different, you cannot just ignore it. But this is a very small parameter. I do consider it. And various parameters like this, like the forecast system, I cannot tell how much runoff there would be tomorrow, but I can get the data. I can get the data from Global Flood Awareness System, which is an international monitoring website, which European based website, which monitors the major rivers around the world and tracks their data. They have developed a sophisticated engine which would tell them how much uh, runoff discharge there would be tomorrow, a future data set. So that's where I get the data. It do not tells you the data that there would be exactly this much. It gives you a range that this is our first prediction, this is our second prediction, this is our third prediction, and there are 50 of them. So I cannot use all 50. That would be too much. The standard deviation, the 90th
Yeah,
percentile, like what is the lowest it is getting prediction and what is the highest 90th percentile
yeah.
prediction it is getting,
But
and these
that's
things.
sounding like a model in itself. Are you
Not,
using
yeah.
another model in your model?
So that is not a model. Global Flood Awareness System is a website which monitors the rivers that discharge throughout the
Ah,
world.
okay. So that takes remote sensing data about precipitation and predicts the runoff.
Yeah,
Okay.
it tries to predict how much discharge the river would have tomorrow and day after tomorrow. But it would be accurate if you just take the discharge for tomorrow. That's what I try to do. So, as an example, if I give these 100 plus scientific parameters to my model and tell it to learn from these, so what would happen is, let's say this one country had a flood, only 10 of the parameters were responsible for that flood. Rest 90 were not so much involved. Not the soil was not so wet, the aridity was low, the evaporation 30 days ago, the 7 days ago was not high. So you can say those parameters were not responsible. Then we go to next flood, and we see this time there were 30 parameters that were responsible. So as you are seeing, as we go through different floods, we would see some are because of different type of parameters, some are because of different type of parameters, and overall when you try to teach the model, it gets confused, and we do not want that confusion. That is why we lower the accuracy.
Okay, so you've started to introduce terms like accuracy and learning as I've
Yeah.
asked you to step us through what parameters mean, and you've talked about some of these parameters. Please, can you explain what you mean by accuracy and learning?
Yeah. So let me go through how this all works so you better understand what I meant with accuracy and precision and all that stuff. So what firstly, I am training my model on global data, as I said. So I am currently manually curating the data for every flood event that has happened for last 30 years. Right now, I have done that for just 7 years. So my accuracy is like 60%, which uh, might sound very low to someone who's not very familiar, but it's still a lot. And let me explain why I say that. The most expensive flood predicting models that are specifically trained to find and detect flood situations and flood conditions and all that are European Union's flood models, and that has an accuracy of 85%. 85 to 95%. 85 to 95%, because you cannot be 100% sure. You cannot predict the nature. And my model with 61% accuracy is just 20 points lower than the world class model. And that's when I have not even trained it on the full data set which I am working on. It's just a 7-year data which I have curated till yet. Uh, it is a huge breakthrough in the sense that not because it's less accurate, but because it can be used worldwide. European Union models which they are using are specifically trained on those rivers, those flood-prone areas which they have implemented on. They rely on very expensive sensors and they constantly monitor the area with engineers and scientists to keep figuring out the climate changes to make new adaptations and all that into their model. So that is why their accuracy has 85 to 95%. And me, someone who have no resources and doing everything manually and does not require my model, which output can be understood by anyone without any scientist and such, is producing 61% accuracy on half of my work, less than half of my work. So you can see the difference. It's just 25 points below the world class flood architecture, flood prediction architecture. And that's kind of making me proud. And even if it would go more higher, but even if it does not, I have a plan for that because as I said, I'm a civil engineer. I do not know much about coding. So I thought this was my original idea, but it is not. It's a very high advanced technique which machine learning experts and such people use. So what I am currently doing is train a global model which can predict flood all around the world. Then the data that it is predicting the flood on, which that would be divided into country and river, these distinctions. So whenever you are trying to predict a flood, let's say in Texas, it would first go through the global model. The global model would provide an result of if it would be a flood or not. That would have an weightage of, let's say, 40-45%. We would take their word to 40% surety. Then my model would go through the training data specifically for Texas and more specifically for that particular river, and then train a random forest model, which are very precise and can work very well with small amount of data. And that would be our local expert, which knows the through and through of that river. And that would produce another result of if it would be a flood or not. And that would be given a weightage of 60%. And that is how my model would create a unison result which would be more accurate than just a global model or just a local expert model.
So I
And
want to come back to
yeah,
this accuracy question. So
yeah,
you,
that's
you
where I was
mentioned
going.
training the model on 7 years of data. So you're comparing it to flood events from the past. Can you step us through?
So the accuracy, the precision I am getting is not from comparison. It's from back testing. So currently my model trains on 80% data. So if I'm giving it 1,000 flood events, which I manually created, it would train on 800 flood events. And after that 800 flood event training, it would test itself on the rest 200 flood events. And then it would try to get its accuracy, like how accurately it can predict the floods and non-floods of those 200 events. That's how I'm getting the accuracy.
Okay, and importantly, it's also the non-floods.
Yeah, no, that's the very very advanced part of the model which I forget and which people do not understand why it is better. So let's say I train my model on flood events. that this is the flood event, this is the flood event, this is the flood event. So my model would get better in knowing if it would be flood or not, but it would not be better in knowing if it is not a flood. As I said earlier, that sometimes even in flood like situations, flood do not happen. And sometimes even when situations are against a flood, flood happens. So it is very important to learn from that. So what I do is I make negative events. So if I am feeding my model 200 events of different floods around the world, on the same location few days before those floods, I would feed my model those conditions. So my model understands what are very similar flood like conditions which do not flood, but what are the real flood conditions. Those are the negative events that my flood also model trains on. So it does not just understand what is a flood, it also understands what is not a flood to better improve itself.
Okay, cool. So we've stepped through the concept of accuracy, got a bit of insight on the number of years of prior events and non-events that you're training on. The topic of training, learning, AI, I think needs a bit more coverage though. Could you, yes, step us through how AI is used?
Yeah. uh, as its name, GeoRiskAI, it just sounds a bit, icky. When I was first thinking of it, I thought it was such a great name that I just slapped it everywhere. It's GeoRiskAI, it's GeoRiskAI. But so people sometimes get a, you know, false sense of AI into it. Like, no, this is not something which is controlled by AI or it is fully AI automated. No, my model is fully ML based, trained on real flood world events. But the AI part is to help you. So what the AI does is these flood conditions are, as I said, when you use my model to get if there would be a flood or not tomorrow. So my model would go through the global expert, through the local expert, use SHAP to understand what are the parameters that it took into consideration to form its opinion of flood or not. And these technical terms, that is why flood models require engineers and scientists to understand it. But because we have AI, my model feeds everything, all of this data into AI directly, and then that AI understands it fully, tries to know what I'm giving it, and I have made a specific prompt for it to understand what I want from it in a very specific manner, very strict prompt. So it takes apart my data, analyzes it, and gives an output. It's an output which anyone can understand easily in easy, simple words. That's the job of AI. It would then
So,
also
so by
suggest,
an AI
yeah,
here, so you made a distinction then between machine learning, you said
yeah,
ML, and that is the basis for the flood prediction service.
yeah,
And you're distinguishing that from AI, which I assume is a large language model or LLM
yeah,
based tool. And you're saying that the
yeah.
only
Gemini
use for
2.5.
that, right? So the only use for
Yeah,
that is to ingest all of the parameters and data used by the ML system to make a flood prediction, to ingest all of that and turn it into a easily understood description of the basis
yeah.
for the prediction.
Understood the basics and uh, things like insights of why it come to that decision and disclaimers and appropriate steps which you can do to further test the conditions, test the ground area, some insights on what you can do in current situation, things like you do a ground testing and all that. These actionable insights for some accountable authority, and for normal people there are explanations and some warnings and preparation to in case. So you cannot take any prediction as a fully guarantee because you cannot predict
Yeah.
nature, as I said. That is
Okay,
why
so at a
it
high
is better
level,
to
you
prepare.
are
Yeah.
sure. At a high level, then you're making the system explain itself to the users or those who are trying to act based on what the prediction says. So, have you got an example or some graphics to
Yeah.
support these comments you're making about ML, learning, AI, and the output?
This is the interactive, the output which you would get from my model. This is just to keep in mind, this is not the final result. It is, you can say, a demo, which as I said, I'm currently in a training period. So I have to make the very early demo, the first iteration. So it would get better over time when I would work on output. So right now, this is proof of concept, and that is why it does not look as high tech as I was sounding. But sure, this is the risk score that you would get usually, and it would tell you how confident it is in its, uh, results output. Like right now, it is 90% confident that there would be a 57% chance of flood.
Gotcha.
Then here is the score of what it thinks the flood range lies in, like 56 to 58% chances of being a flood. Then here it tells you about the data it used. So as you can see, it right now it took 10 kilometers area and 10,000 pixels, and all the pixels were present. It get a coverage ratio of 1. If it gets a coverage area ratio of zero point 0.8 or lower, that means there are clouds hindering it to not, so it is not able to get accurate data. So it would cancel that output. You can then tell it to get a previous data, like data from a few days back or so if you want, or you can wait till the new image come up which are clear, because we do not want our model to make assumptions. That is why it would either reject it or ask you to wait or use a previous data. Then these are the actionable insights, what you can do in this area. Immediately conduct comprehensive on the ground survey across the entire area. These are the coordinates of the area, and you can do this, that. Then it also produces a map of the area and the sensitive zones in that area. As you can see.
So, what does that map mean?
So right now it is a heat map. So it does not mean much. It is currently showing the heat sensitivity of the area and all that. But when I am making it into a final iteration, the map would be a very important feature. The map, the orange part of the map would show you the dangerous clusters of the dangerous areas which it would think are more likely to be tested or can be more of a, you know in danger zones
For a
of the
flood.
area. Yeah, for a flood, if a flood occurs. So that's what a map, this type of map would be. But
Okay.
right
Is
now
that
it's
somewhere in
just
the
a heat map.
Himalayas?
Yeah, near Himalayas, it is
Okay.
near Uttarkashi mountain area range.
Okay.
Here, because it is a very steep area, and there are snow as well. Sometimes snow melts and the steep area uh, does not hold the water well, and there's a flash flood in an instant.
All
So
right.
this
So
is
yeah,
the,
that's
yeah.
still a prototype. Yeah.
Then, as I was saying, this is the perform. Right now, I am here at the beginning. Then as soon as I keep feeding it all the data, my goal is to get it at least 70 to 80% accurate so that it can be a professional level. Even at 60%, it is better than a research model. And when it gets near 80%, it becomes a, you can say, a world class type of tool, because lots of tools that are being used has a range of 80 to 90% in their predictions. As I said, nature being unpredictable, and so then I always say that I use AI as my partner in coding. I'm a civil engineer, so I do all my research and debugging and getting all these innovative ideas, solutions to problems which AI come up with. But I orchestrate everything and AI help me code faster. So people, as soon as I say I use AI for my coding needs and help all that, people generally get sensitive about it, thinking that AI is doing everything and not knowing how much work goes behind making the AI understand and making getting the help of AI. Sometimes even the working code can become crippled when fed to AI, because AI can hallucinate a lot. And yeah, I'm not going to badmouth my partner much, but it is really difficult to work with an AI if you are not experienced in coding. Then uh, these are the next steps. So, as I said, flood and landslides have very similar parameters, such as the soil and moisture and all that, vegetation and such. So, after the flood modeling is all done, I'm thinking of training this model on landslides as well, because there are lots of landslide prone areas. So, what the final, so I can finally be able to call it GeoRiskAI, because it would really be working on all the risks related to such disasters. That's the next step. It would take a while to finish this and go to that, but it's no harm keeping it in a vision. Then,
Okay.
yeah, that's just it.
Yeah, great. So I've got a couple of questions remaining. Um,
Yeah,
can you tell us about some of the challenges handling the data?
yeah. Challenge. I this There are so many challenges. I just cannot name one. But if I have to, let's start with the very basics. You cannot get the data uh, that you would want to have. So if you look for free data, you would most likely get EMDAT, emergency database, where all the events are worldwide are noted. In that database, you will get the name of the area, the location sometimes, and the population that got affected by that, and that's about it. Not nothing you can train your model on. So what I do is I take that data year wise, and then I manually find out every event that happened on that area. Like sometime it would mention that there was a flood in this country, and that then not even give you the location or the river name where it flooded or anything much. So I have to go to that time period, scrape all the news outlets of that area to get what flood there was, to finally make a good data set of all the floods and their latitude, longitude, their dates. And so I can show you an example. So as you can see, this is how I curate all the data. Like first the location, then the dates, then the latitude and longitude, then what river it was, what type of flood it was, how much confident I am in this data, the areas which were affected, the uh, you know townships which were into that. the country
So
code,
is this
what
a
type of,
CSV or
yeah,
a tab delimited file, something like that?
yeah. This is just a text .txt data that I curated, and then uh, I just keep adding all this into a text file. Then I add a reasoning to why I thought it was a flood event. Then I feed all this into an AI to fact check me. And if there is a AI cannot do all this in one go. And because I am resourceless, I cannot buy a paid AI uh, to work for me throughout the day. I can just upload 10 files in a day, so I want to make it count. That is why I have to manually curate it, and
Yeah.
then I feed it to AI, get the results and all that. After
I,
that,
I
the checking is done. Yeah.
Yeah, I
So
remember you said there was a huge amount of data you were trying to extract across several Google Colab sessions, and there were
yeah,
challenges there.
yeah. Let me show you this as well. This is the final training data which I curated. After all that is done, when I have fact checked, then I finally make this data set. It has uh, all the features that I want to train my model on, such as the look back, the 7 day look back, how it was throughout the 7 days, the mean of the rivers, ROW means runoff, then the mean of their discharge, the soil moisture, then uh, Google Earth engines, precision, this, how can I make it more understandable? I just say scientific parameters. These are various parameters which I was talking about. The
Yeah.
precipitation of 3 day sum, 5 day sum, 7 day sum to so model finally understands what
Are
was
these
the
the
past parameters.
are these the 110 parameters
Yeah,
you've been talking about? Okay, so it's
yeah,
all in this sheet here. Amazing. Um, Cool. So that does give us a flavor for the challenges of data wrangling. That
yeah,
also brings up I know there's more to say about data challenges, but just in the context of you having these parameters here in front of us, um, you said on LinkedIn, as
yeah,
I mentioned at the beginning of this episode, your model lost accuracy by introducing more parameters.
yeah.
So I just want to bring things back to that. What was the reason?
So the reason was I was naive. I was training my model on the flood events, like flood day event. Like, let's say there was a flood today, so I was giving my model the what happened today, like how much discharge there was, how much precipitation there was, and all that data. So it is wrong. I know it sounds weird, but it is wrong to feed the model this, because this is called leaking. This is the data I cannot provide my model if I'm checking for future, if I'm checking for if there would be a flood tomorrow or not, because it does not know how much discharge there would be tomorrow, how much runoff there would be tomorrow. It does not know that, and I cannot provide it that data. So if I'm training on my model on this data, which I cannot provide on the time of assessment, then that's leaking. That the model would not be able to depend on such an important parameter. So after learning from this important parameter, my model was providing an output result of 84%, which was so mind-boggling. Like, it was a result so close to a European Union's flood model. As I said, a world-class tool. So close to a world-class tool that it was just, I was over the moon when I saw those results. And I tested it again and again and again, and the result did not change. But then I finally understood why it was happening. I fact checked myself few times, and then I realized I cannot provide this data. And if I gave it a prediction, like, as I said, global flood awareness system provides a prediction of what discharge there would be tomorrow. So if I give it that prediction and it compares that prediction to the real world flood data, there would be discrepancies. So it would not be able to provide a good result. That is why I have to remove all that to finally train it on the forecast data. So I'm currently training on it on forecast data, like how much forecast the global flood awareness system forecasted it to be discharged today. So if it's trained on that, that's the data I can provide for tomorrow as well, because it's a forecast. So that's where my model has to find a connection in all these years of training data.
I
This
have
is
to
why its
say,
accuracy is low.
sure, okay. I'm struggling to keep up. Could you explain it again, specifically the types of parameters that you should not include that gave a false sense of accuracy?
Yeah. So data which you cannot provide on the day of testing is a leaking data, is a false data. You cannot you cannot train your model on a false data. Let's say if I am training my model on that particular day, like told my model that this was the data. If this happens, there would be a flood. Then when I'm asking my model if tomorrow would be a flood or not, my model would ask me to give it that data which I trained it on. But now I cannot provide that data because that is for tomorrow. That data has not been recorded yet. So I cannot provide that data. What would happen is my model would get confused. It would leave that important data and not provide a good result. So I have to train it on a forecast data. So the data currently I'm training it on is the forecast. Like on this day, the global flood awareness system thought that there would be X discharge tomorrow. Then that is what my model trains on. Then when I'm testing it, my model would ask me what is the X discharge that is forecasted for tomorrow. And that is something I can provide. And when I provide that, my model would be uncertain because forecast is never 100% sure, but it would provide a real result, not something fake, which
Okay, so
it cannot comprehend.
you're saying that the kinds of parameters that work are ones like the forecasted amount of precipitation, and also feeds of data about soil conditions, the permeability of the surface,
Yeah,
the amount of rainfall over the past week or month to
those
estimate
data
the,
are those data are providable because those are
yeah,
past data. How
yeah,
much rain there was tomorrow, how much soil wetness there is
okay.
right now.
But we
So
also
that data
have,
is providable.
I
Yeah,
understand, but there's a temptation because it's the past, so you have a perfect record of the locations, dates, and times of the flood events themselves. And you're saying that you should not train it on the flood events themselves because
yeah,
the whole point of the system is to predict those occurring using all of the
yeah,
data around the occurrence of those events. So was it the error that you were including the locations, dates, and times of the flood events themselves?
yeah.
That was the
So
leakage?
yeah, the leakage was the historic on-day data,
Yeah.
the data which was on the day of flood, because I cannot provide the data of today.
Ah. Okay, so
So
it's
if
not
I
just whether or not a flood occurred, but it's also because you've got the next day prediction for the precipitation, but then in your historical data you also have how much rain in fact did fall. So you're saying
yeah,
you can't train it on those data either. Okay.
you you cannot train it on any data which you cannot provide it right now, right the instant the model is running.
Yeah.
So yeah, that's the very basics which I did not understood at the time.
Yeah. Okay. All right. Cool. Good. glad you to uh, take the time to clarify and begin to dig into this complex issue of yeah how to deal with all these parameters and the risks of handling them without fully understanding them.
That is why people say it is better to only go into do things which you are more knowledgeable about. When I started this,
Yeah,
I did not know anything about machine learning, coding, how to curate the data set, what to train it on. But over the past month that I've been doing this, I'm gaining so much knowledge, so much understanding of the work and everything that I'm constantly evolving myself and the thing that I'm building. It's
yeah.
going one level up every day, I say.
Yeah. So about that, I think we can, in closing, return to this event for New York Climate Week that you participated in at St. John's University last week. So you were saying that another challenge with data handling is that you're having to run multiple simultaneous Google Colab sessions or something like that to download in chunks
Yeah.
large data sets, and there are some challenges with assembling it at the end of that. You're always having to work with what a free tier of these various resources can provide for you. So I raised that topic with Ryan Abernathy and Tom Nicholas of Earthmover, who gave the final keynote during that tech workshop. And, you know, I think they had some interest in talking with you. They said that, you know, a way for you to deal with the challenge of having regular blackouts, you said that, you know, earlier this week you had 3 days of blackouts because it took them 3 days
Yeah.
to replace a transformer. And anyway, you're dealing with only 8 to 10 hours of power per day. So they said that there is a way to use compute resource in the cloud to run, you know, your Python notebooks or whatever. So effectively, none of your work is done on a local machine. So has could you talk a bit more about this challenge of, you know, these multiple Google Colab sessions you're having to run,
Yeah.
and whether you've had any thoughts about what Ryan and Tom were saying, and you know, if you have any hopes for collaboration with them or learning from them, and the kinds of technologies discussed in that workshop.
Okay. So collab sessions. So the thing is, as I said, I currently have no resources. I cannot pair anything to this. The thing is, all the data which I am training my model on is a very huge data. So I have to download the data for first 15 days of a month, then train my model on those first 15 days. The first 15-day data can be up to 15 to 20 GB, which is huge. It takes a lot of time to process on the server and then send it to me. Then the Collab downloads it. Collab has a download speed of 100 Mbps, which is very good, but servers cannot send the data at that speed. Servers send the data at 2 to 3 Mbps. So the downloading can take up to hours for 15 to 20 GB of data to download on Collab. Then after that, it is opened every single time because right now Collab free there is a limited RAM on Collab, so it cannot open that keep the data set open for me to train every day from that open data. So I have to do it in a certain way that open the data set, get the data for a particular day, then close the data set, then open the data set again, search for a particular data for a day, then get that data, then open it again. That's how I have to do it to not go out of the collapse RAM usage. And that takes a while as well. That takes hours as well. So after 2 to 3 hours, I can finally get 15-day data. Then my pipeline deletes that request for a new data. That new data gets processed, send, and after, you can say, 6 hours or so, finally 1 month of data set is curated. And that's a challenge because the data set I'm trying to curate, make is should be at least of 30 years to be something good. And for 30 years, this process can, as you can already understand, if 6 hours stay a month, so 30 years has what, like uh, uh 36
We're talking about terabytes.
yeah,
Yeah, so
terabytes
this,
of
I guess
data.
I wanted to, so some context here. So Tom Nicholas, in his demonstration of Earth Mover in a Marimo notebook, not just a Jupyter notebook, that's an interesting new development there. He was demonstrating, in minutes, doing some analysis on 40 terabytes of historical weather data. So I just thought this was a really useful contact for you, or technology or set of approaches. I
Uh,
think if you haven't seen that notebook, I can
yeah,
share it with you, and I think it's just worth stepping through it and understanding what Earthmover is showing can be done. There's a whole lot to do with formats like is shown on the stickers on the back of my phone that I got from the event. You've got ZAR, X-ray, ice chunk, that are used routinely with Earthmover. So it just made me feel like there's a chance. There's a lot of heavy lifting you're having to do, but you've got the world's worst circumstances to try to lift some of the largest, heaviest data sets in the world. So yeah, I feel like there's potential there.
yeah. The AI keeps suggesting me to pay $20 to get it better. But as I said, $20 can be a lot if you multiply it by 90, which is a ratio. So I just cannot do that. So I have to keep coming up with ideas to make it work faster. So I made a Google Earth Engine account in various browsers of my machine. Then I created a collab account for all those. Then all in all those browsers, I open a new collab window and make a pipeline that requests two data at once so that it is being processed at a time. Because if I request all those data at once, there is only so much data that the server can process. So even if I ask everything at once, it cannot provide me that because it takes time to them for them to process all that data and then send it to me. So it's not something that one can do to just request everything at one go, download it bit by bit. No, the data that they have processed, they delete that in a day. So you have to use it within a day. So you cannot just process it and then download it bit by bit and such. So I have to make pipelines that go through those you know restrictions and open it through various browsers, through various accounts, to uh, from 6 hours in a month, I'm doing like 3 months for in 6 hours. That's like triple the speed. It's still very slow, but it's triple of what I was doing initially. But yeah, sometimes I see these videos on YouTube and such, where people ask me, where people are, I am a big foodie, if you can tell by my size. I'm real. Right now you cannot see me, but I'm very big in size. You can say 85 kgs, which is like 160 pounds or so.
Yeah. I,
So I'm a big foodie. I get all these videos, shorts, YouTube shorts of people spending uh, like for for them it's like $20, $30 on a pizza, on a burger. I'm like, bro, if I just had $20, I would love the pizza, but I would like to do my work first with that.
Sure. Right. Okay. So you're really bringing things into focus in terms of the economic differences, the difference in fortunes around the world, and really what you have to fight through to just achieve the outcomes you've achieved so far. Okay. So I know that you've already been connected to Ryan and Tom. So I
I've
hope,
not being able to exchange any message right now, or talk to them, or as I said, I was not able to watch the presentation, and right now I'm connected to them, but they have yet to either see my message or reply. I don't know, but yeah, I'm just I just try to spread my net to get as many people to you know uh, exchange words, exchange perspectives, exchange knowledge. That's how I can get more innovative idea to finally work around. As you said, the terabytes of data processing, that's a really awesome thing. I try to look, other alternatives, but it is really hard to find any alternative which is better than Collab at this moment. I tried the Kaggle notebook, which is better than Collab, people say, but I just cannot get it to work no matter what I do. So
yeah.
I'm stuck
Okay.
with Collab.
All right, so at least I'll send you that Marimo notebook. You can, I mean, if I was able to step through it just in the library along with a whole lot of others without too much trouble, I think you should be able to fight through it as well. So that's, maybe a way to get started. And I think honestly, what at least you've demonstrated is the appetite for this work. You've demonstrated an understanding of the first principles involved. And determination to fight through the challenges here. So the next thing shortly is some sort of a roadmap. It looks like you have that slide from your presentation about what could be next. You've got a good description, I think, of the challenges that can be overcome with sounds like a minimal amount of funding. So there's surely a case that can be made to organizations that provide funding, based on the work that you've done so far.
Yeah, I my right now I'm currently working on this as in my free time. So I just let the collab run in background while I'm cramming all that. But if that is the thing that I am currently uh, learning for my competitive exams, cramming all that, that is good. That is like a secondary motive, because for for as young as I was, I always wanted to do something, not to make a name for myself, but to do something through our environment, through as I've lived through very various difficult, extreme circumstances. I wanted to make the world a better place since I was young. So what I am doing right now is some as a trying to get by, to get a job, to finally
Yeah,
get by through all these
yeah,
circumstances. But the flood model, the heat maps that I create, and all that are part of something that I truly wanted to do, and I am doing that as much as I can in my free time. And for a roadmap after that, I'm looking for a landslide prediction model
yeah,
integrated into GeoRisk AI, and now I'm trying to evolve my heat risk map into the heat. As you have seen, heat waves are very deadly as well. So right now my urban heat analysis map can find hot spot and cold spot in an area if tweaked a bit more and use embedded images which have all those data of particular area. It and feed it the monitored the death rates and the heat which caused it properly into that model. I think it would be able to send out heat wave warnings as well. So
yeah.
that's the third motive, and it
So
would
it
keep
sounds like
going on,
there's
I think.
almost an emerging, literally geography related risk AI tool. It's a
Yeah,
suite
yeah.
of, it's a prediction suite really, for survival in the our kind of say increasingly erratic climate. And the predict like it reminds me of the episode that I did with Alpha Geo. Michael Ferrari was a really great guest. AlphaGeo has a heat prediction or climate change prediction map for the next 100 years, and India shows up as this deep pulsing red,
Yeah.
area on the map in 100 years, basically saying that it's almost going to become intolerable to live in due to heat. So, the areas that you're working on with this system are all really worthy, and literally with proper execution and implementation should result in fewer lives being lost. So all of this says that, to me, with a bit of work, a compelling case for funding can be put to, I don't know if there are local funding sources in India, surely there would be, or elsewhere, like the global, large humanitarian funds, the Gates Foundation, etc. So all of this sounds to me like, along with, sources of coaching for you from, the tech community that you were introduced to through this workshop last week, but also through the philanthropic circles or that scene, that's also a useful next step for you.
I never thought of getting funding or going to going through this uh, going through this. I always thought of it as a humanitarian tool for everyone to use and such. So it never crossed my mind to get a funding to ask for money or anything. But and as I said, I don't have a very broad worldview. So in a sense that I do not know a lot of things like how to get started, and sometimes this can get very scary. Getting talking to different people of to which you have nothing in common with, to for your personal gain or something. And as I said, it never crossed my mind, and it was something that I never thought I should do, but I should do. And it's very confusing for me because
Yeah,
uh, I've never been through all this before. Even
yeah.
right
I
now,
mean, the
as I'm
funny thing
thinking, I'm
is,
lost to words.
yeah, because of political changes in the US, USAID has been cancelled. That would have
Yeah,
been also because they have funded all sorts of amazing humanitarian campaigns and interventions around the world. I'm even aware of them, for example, providing funding for the 400-kilometer long Lebanon Mountain Trail, which is, something that's been a source of tourism money for foreigners walking up and down that mountain trail, right? So if they were even funding small things like that, then of course, a flood prediction, landslide prediction, and heat wave prediction service would definitely have been something that they would like to land money on. So now that they're gone, we have to look at other things. But all of this that you have done so far and the description of the challenges and the roadblocks, there are plenty of other funding sources which are all about removing those roadblocks so that this kind of important service can be rolled out or developed. So yeah, I just want to say that it's worth spending some effort on that as well. I'm happy to think about it. I have limited network there, but there's no harm, I think, in you beginning to talk about that on LinkedIn as well, to see if you can attract people who have an interest in solving things from a financial perspective, so that the technical challenges are easier to deal with.
yeah, I think I should make another killer hook for that as well.
Cool.
uh,
Okay. So yeah, that was a great tour of all the effort that you've been making. As you said, around the sidelines of your efforts to land. Sounds like a highly competitive job in the Indian public service. So yeah, good luck with making it through those exams. If they finally do hire you, it's a testament really to the talent of who does work for the Indian public service. But I have to say, you're already showing that you can make progress, make an impact regardless. And I think even if you're not successful there, with some focused effort, some strategic work, especially around the funding side of things, I think there's a future there for you as well. So thanks. For the podcast is definitely about highlighting the kind of ambitious and determined individuals like you. So yeah, thanks for being a part of the show to show people how it's done.
Yeah, thanks for having me and helping me spread the word and put myself out there. And it was a pleasure knowing you and doing this as well.
Actually, so I've had a couple of people on who have some participation in the UN. One of them that sticks out is Nadine Alamay. And she has a master's from MIT. Funnily enough, she's also from Lebanon. So I think actually that is a direction I can go in terms of your networking. I can connect you with her, and she moves in these kinds of circles. Her network generally is extremely broad from a technical and a humanitarian perspective. And there's another connection to someone else on the same board at the UN. I've recorded episodes with both of these individuals. So what I'll do next is connect you with them, and they then should help you to propagate this message out through their networks to funding sources and bodies and sources of inspiration in that direction. So yeah.
Yeah, that would be really great. I think spreading the even if I do not get funded, I think spreading the words that what I am making is totally free and for various communities who can adopt it if they knew about it, if they can follow the work and if they use it, that would really create a purpose to what I am doing. Not just publish it and then let it dust out, rather than spreading the words to as many people as I can. So it would help me in any way, even if the funding is not there. The expansion of my network and people to know my work.
Yeah, that's the next step for me is to help you grow your network and stay in touch and hopefully have more updates on LinkedIn about your progress. Thanks, man.
Yeah, thank you.